Okay, we're back for some more equations, and they're going to be a little bit more complicated than they were on the last video, but still the type where we get unit circle locations and we solve with no calculator. All right, so the difference in these, what these will look like is if you notice the argument of cosine right here, it is something other than just theta, which adds an extra couple steps. What we're going to do is we're going to isolate the trig function. That's what we did last time. Then we're going to apply the inverse, which we also did, but then we're going to isolate the, in this case, theta, or whatever variable is in that question. So I'll show you how that works. First, in this problem, we need to multiply both sides by 2 to get rid of the 1/2 on the right and therefore isolate the cosine function. So if I multiply by 2, I get the square root of 2 over 2 equals the cosine of negative 3 theta. And they don't put parentheses around it all the time, but that might help just reinforce the fact that we are taking the cosine of negative 3 theta. Now, I didn't see a nice unit circle number at the beginning, but now I do. It's square root of 2 over 2. So what I would have done last time, I'm going to do here. I'm going to think about where does the cosine equal the square root of 2 over 2. And that is step 2, applying the inverse. Okay, so cosine is positive square root 2 over 2 in the middle of the first and the fourth quadrants. We are in degrees here, so that's going to happen at, I can say it in a few ways. I'm going to call this 45 and 315. Now, that's not what theta equals. That's what negative 3 theta equals. And now here's another little catch. I just had to list the two values last time without this negative 3 in there with the theta. I would say 45, 315, and I would be done. Because my domain was only 0 to 360. Here's the difference. My last step to sneak ahead to step 3 is going to be dividing by negative 3. So what happens there is there are values outside of 0 to 360 that when divided by negative 3 come into 0 to 360, if you know what I mean. What that means for you is you need to add 360 degrees in to each of those. We've solved questions with infinitely many answers in the past, and that's what we need to do here. Now isolate the theta in each by dividing everything by negative 3. So in this first equation, I get 45 divided by negative 3, which is negative 15, plus 360n divided by negative 3, which makes that negative 120n. So I'm approaching this as if I'm finding the infinite number of solutions, but then I'm going to let n be 0 and 1 and all those numbers to get the ones that fall between 0 and 360. Over here I get theta equals, let's see, 315 divided by negative 3, that would be negative 105 minus 120n. All right. At this point, I let n be values, integer values, that will make final answers between 0 and 360. So starting with this first one, if I have negative 15 minus 120n, then let's see, if I let n be 0, I get negative 15. If I let n be 1, 2, 3, I'm going to subtract 120 and just get further into the negatives. So technically, I need to let n be negative 1. So if n is negative 1, then I end up doing negative 15 plus 120, which gives me 105 degrees. If n is negative 2, then I'm going to add, because again, negative, negative, I'm going to add another 120, which gives me 225 degrees. And I'm going to keep going until I get up to 360. If n is negative 3, then I'm going to add another 120, which gives me 345 degrees. And if I add 120 again, I'm going to go beyond 360. So the left-hand half of this equation gives me 3 possibilities. So let's move over to the right. Again, if n is 0, I get negative 105. I don't want that. If n is positive, I just keep subtracting 120s, and I don't want that. So I need n to be negative 1 also. If n is negative 1, theta is going to equal negative 105 plus 120, which is 15. When n is negative 2, I'm going to add another 120 and get 135. And then negative 3 gives me another 120. That makes, 255. So when it's all said and done, I have 6 answers. Theta equals, I'm going to write them in order, 15 degrees, 105 degrees, 135, 225, 255, and 345. All of these are values that will make your equation true. So that's why this one's called a little more complex, because of that process there. You treat it like there's infinitely many. You can't just use the main 2, the 2 between 0 and 360. If you do that, you're going to leave out a lot of answers. So treat it like it's infinite, then apply n values that will give you final answers between 0 and 360. Okay, so I'm going to skip, for the sake of time, I'm going to skip down to this question. Because it's a radian question. I'm still just looking for 0 to 2 pi, but this time I'm going to deal with radians. Okay, so I'm going to isolate the trig function. That's going to involve a couple steps. I'm going to add 3 to both sides to cancel out the minus 3 on the left. When I add 3, I get 1. Now I'm going to multiply by 2, both sides, to get 2. And cosecant equal to 2, that's good, because that means that the sine of negative theta plus pi over 4 must equal 1/2, since sine is 1 over cosine. And I can actually change it over and just approach this like a sine problem at this point once I get my cosecant isolated. All right, so I've isolated my trig function. I've actually changed it to sine, but I have an isolated sine function at this point. All right, so now I approach it like the infinitely many case. Even though my final answers are only going to be once around the unit circle, as we saw in the last one, if I do that, I might leave out possible answers. So where does sine equal 1/2? That happens here at pi over 6 and here at 5 pi over 6. Excuse me, I forgot my plus 2 pi n. In this one, I'll show you how that's not going to matter. I could have just gone with the 2 straightforward answers, but I want to show you why. So negative theta plus pi over 4 equals pi over 6 plus 2 pi n. And my other option, negative theta plus pi over 4 equals 5 pi over 6 plus 2 pi n. The times when I'm going to get more answers are when I kind of have a multiple of theta, like I did up here. I had negative 3 theta, which when I divide by that 3, I kind of squish the unit circle, 3 unit circles into 1, if that makes sense. On this one, I don't really have a multiple other than the negative 1, so I'm not expecting extra answers, but just in case, it's a good habit to do the plus 2 pi n. All right, so now what I need to do is subtract pi over 4 here, both sides of the equation. And this doesn't apply to all parts because I'm just combining like terms. So I have negative theta equals pi over 6 minus pi over 4. I'm going to need a common denominator to add these things, which would be 12. Just kind of off to the side, pi over 6 minus pi over 4 would be 2 pi over 12 minus 3 pi over 12, which is negative pi over 12, plus 2 pi n. Okay, sometimes, you know, doing some steps in your head, sometimes it's all right, but don't do too much. Just get a scrap sheet, go to the side, figure stuff out when it's necessary. Now I'm going to multiply everything by negative 1, including the plus 2 pi n. But really, if you think about it, that doesn't matter, because n could be any number, plus or minus 1, or plus or minus any whole number, so we're fine. So my final answer, based on this half, is going to be pi over 12 if n equals 0. But if I go a full rotation around the circle, because I still have 2 pi n, I'm going to be outside of the 0 to pi over 2 window. So pi over 12 is my only answer. On this half, negative theta equals 5 pi over 6 minus pi over 4. So that would be 10 pi over 12 minus, just a moment. See, I tried to do too much in my head. I'm going to do this like I just suggested you do. 5 pi over 6 is 10 pi over 12, minus pi over 4, which is 3 pi over 12, is 7 pi over 12. Good. Negative theta equals 7 pi over 12 plus 2 pi n. So now I multiply everything by negative 1, get negative 7 pi over 12, minus 2 pi n. Again, that doesn't matter. So my answers are going to happen at negative 7 pi over 12 or any full spin around the circle from that reference point. So if I add 2 pi to negative 7 pi over 12, that's 24 pi over 12. I end up at 17 pi over 12. So I did the infinite, the plus 2 pi n deal just to be safe, but it turns out I just needed the one main answer where n happened to be 0. And that's because theta did not have a multiplier on it other than just a negative 1. All right, so quickly, I want to show you what happens if we do have infinitely many solutions. It's actually a little easier because we don't have to sort out which ones are between 0 and 2 pi. You just kind of leave it. So let's isolate the function. If I add 3 to both sides, I get negative 8 on the left. If I divide by negative 4, I get 2 on the left. This one is similar, except it's a secant. If secant is equal to 2, that means cosine is equal to 1/2. And my function is isolated. So now I think, where does cosine equal 1/2? Well, cosine is a half here at pi over 3, and here at 5 pi over 3. So the argument of my cosine function must equal pi over 3 plus 2 pi n, or the argument of my cosine function must equal 5 pi over 3 plus 2 pi n. And now if I can isolate the theta, I'll be done. So on the left, that's going to involve subtracting 5 pi over 4 from both sides. So I need to know what pi over 3 minus 5 pi over 4 is. Pi over 3 minus 5 pi over 4. This is just side note, scrap work. That is 4 pi over 12. And then to get 12, that's minus 15 pi over 12. 4 minus 15 is negative 11 pi over 12. Plus 2 pi n. All right, like terms, the 2 pi has an n on it, which makes it not a like term. And then if I divide by 4, both sides, negative 11 pi over 12 divided by 4 means just basically multiply the bottom by 4. 12 times 4 is 48. Also need to divide 2 pi n by pi over 4. And 2 divided by 4 is a half, or in other words, pi n over 2. All right, so make sure that makes sense. When you add to both sides, you just do like terms. So I didn't involve the 2 pi n. But when I divide everything by 4, I divide everything by 4. Okay, and then this side, which I'm going to let you work out on your own, you should end up with 5 pi over 48 plus pi n over 2. And those two together, I don't have to try to figure out, what ends will make this stay within the once around the unit circle. So it's actually a little bit easier, in my opinion. So there's that one. So we've got some degrees, some radians, some infinitely many, some finite amount of solutions. And then finally, just try this. You should get, for number 7, 75 degrees, 165 degrees, 255, 255 degrees, 345 degrees. All right, so obviously you're going to have to do that one on your own. It might make a good quiz question. You never know. So you should try it. All right, so let's call this one off before it gets too lengthy. Trig equations, day 2. I'm out.